The topic of this presentation will discuss the difference between gram-negative and gram-positive bacteria. So let's get started. The cell wall of a gram-negative bacteria has a very thin peptidoglycan layer. It makes up only about 10% of the cell wall. It's also very waxy. In addition, it has a low inhibition to basic dyes, meaning that it doesn't retain or hold dyes very well. It also has a low susceptibility to anionic detergents. Most of the cell wall is composed of an outer membrane with a structure called lipopolysaccharides, also known as LPS. The LPS is made up of three components: lipid A, core polysaccharides, and O antigen polysaccharides. Lipid A is a type of endotoxin that is composed of glucosamine disaccharides and lipids. And lipid A's are only released when a bacterial cell dies, and they can cause a very strong immune response when there are a lot of lipid A's released at one time. And this is why doctors want to be very cautious when prescribing certain antibiotics to patients, because you don't want too many lipid A's released in the body at one time, because then the patient can have a fever or go into shock. Then core, they're just repeated subunits of polysaccharides, and then O antigen polysaccharides, there are approximately 40 subunits, and they branch off of the core polysaccharides. Lastly, the key difference is the periplasmic space, which is a gel-like matrix in between the inner cytoplasmic membrane and the outer membrane. This next slide just shows a cross-section of the gram-negative bacteria. And as I was saying, you can see a very thin peptidoglycan layer in between the cytoplasmic membrane and the outer membrane. And here in the cytoplasmic membrane, you can see the phospholipids and the tails hanging. And then moving on into the outer membrane, you can see that the porins are embedded in the outer membrane, as well as proteins. And then you see here are the lipid A's. And then moving into the outer membrane, you have the core polysaccharides right here. And then branching off the core, or moving to the outermost part of the outer membrane, are the O polysaccharides. Now moving on to the cell wall of a gram-positive bacteria. So gram-positive bacteria have a very thick peptidoglycan layer. It makes up about 90% of the cell wall. The cell wall is also very smooth. It doesn't have an outer membrane, and it doesn't have a periplasmic space. Instead of producing endotoxins like a gram-negative bacteria, it primarily produces exotoxins. And exotoxins are just the toxins secreted by bacteria that are released outside of the cell. They have a high inhibition of basic dyes, which means they're very likely to retain a lot of the dye. And they also have a high susceptibility to anionic detergents. They're also very common to contain teichoic acids that are embedded in the cell wall. And in addition to teichoic acids, they can also have lipoteichoic acids, which are just teichoic acids covalently bound to membrane lipids. And in this next slide, you have a cross-section of the gram-positive, and as you can see, a very, very thick layer of the peptidoglycan. And then you have the lipid teichoic acids and the teichoic acids embedded in the thick peptidoglycan layer. And then here you have the cytoplasmic membrane, phospholipids, and then you have the tails. And then this next slide is just reiterating what I was saying in the previous slides, and it also gives a different angle of the cross sections of the gram-positive and gram-negative bacteria. And it just goes to show that just looking at this angle, noticing the differences in the peptidoglycan layer, a very thick one in the positive and a very thin one in the gram-negative. And you can see that the outer membrane, there's an outer membrane in the gram-negative, and that there's no outer membrane in the gram-positive. Now moving on to the color of gram stains. So gram-negative and gram-positive, they produce a different color. So this is a common way to test whether you have a gram-positive or a gram-negative bacteria. A gram-negative is going to produce a red or pink color. So this is going to be after the decolorizing step in the gram stain process. In gram-positive, the bacteria is going to produce a purple color, and this is because it has a very thick peptidoglycan layer that's going to retain the crystal violet dye. And once again, the gram-negative is very thin, so it's not going to hold on to that crystal violet. Is going to be washed away, and then it's going to be counterstained with safran to get that red color. Now moving on to the flagellar structure of a gram-negative and gram-positive. So in the gram-negative, it has 4 rings in the basal body, and these rings function as bushings to increase support and decrease torque. And the reason for this being is that gram-negatives, when you have the flagella going into the cell wall, remember it's going into a very thin peptidoglycan layer and is in addition to a periplasmic space. So that's offering very weak support to flagella. So it has additional rings so it can anchor the flagella and provide that more support so it can prevent destruction in the cell wall. In the gram-positive, support is not that big of an issue because it has a very thick peptidoglycan layer and it only needs 2 rings in the basal body. Also, gram-positive bacteria tend to move in straight lines or tumbles. This next slide, it just shows the differences in the flagellar structure of a gram-negative and gram-positive. And as you can see, there's an addition of 2 rings. In the gram-negative, you have the addition of the L ring and the P ring. And then once again, you can see just that flagella going into that very thin peptidoglycan layer and that periplasmic space, so it needs those extra rings for its support. And then in the gram-positive, you can see it going into the very thick peptidoglycan layer, so it doesn't need that much support. It only needs 2 rings. And the flagella, notice that both of them is like a hook-like shape going into the cell wall. Lastly, pathogenesis is very important in knowing whether you're dealing with a gram-negative or a gram-positive bacteria. Approximately 90 to 95% of gram-negative bacteria are pathogenic. In contrast, many gram-positive bacteria are non-pathogenic. And pathogenic is just the ability for a bacteria to spread a disease. So gram-negative bacteria tend to be more harmful than humans simply because they're more resistant to antibiotics. And I think I mentioned it before in a previous slide, but once again, gram-negative bacteria, the reason why they're more resistant is they have that periplasmic space that can sequester molecules. And also because it has that outer membrane, it can protect the bacteria from antibiotics, also dyes and detergents, etc., going into the inner membrane. So this will conclude the presentation of the difference between gram-negative and gram-positive bacteria. But just to highlight the key points, we talked about the differences in the cell wall structure, the flagellar structure, color of the gram stain, and pathogenesis in humans. I hope you enjoyed this video.